visiting amarpathshala.com. As you can see, our lecture today is about atomic structure in the periodic table, and this is part 3, which is the last lecture from this chapter. In this lecture, we look into electronic arrangement, the periodic table, and electronic structures. We begin our lecture by talking about electronic arrangement. So guys, to understand the arrangement of electrons in an atom, we have to first look into the figure or the structure of an atom closely again. So as you can see in the diagram in here, the strong positive or the center is the nucleus, around which are rings, which are numbered 1, 2, 3, and 4. And on them, electrons are moving around. So the thing is, guys, electrons, which are negatively charged, are moving around the positively charged nucleus. But then again, why are they doing so, right? Like, why aren't they moving way further, or why doesn't one electron from one element just randomly move into the next? This doesn't happen because the strong positive nucleus of each atom is holding the negatively charged electrons by an attraction of a strong electrostatic force. That force is putting the electron in the orbit of the nucleus. The electrons are moving around, and when the electrons are moving, around, and the closest electrons to the nucleus is undergoing the strongest electrostatic force of attraction. So, in order to understand this force of attraction or the attraction of one particular electron from the nucleus even better, we have devised a form of shells. Shells are considered form of levels, like, you know, when you ride your elevator, and you ride the elevator from ground floor and then to the first, to the second, third, fourth, and so on. These are the levels, right? So in an atom, it is assumed that around the nucleus, the closest level, or the electrons that are closest to the nucleus, are occupying the first level or the first shell. And then on the second shell, and then third, and so on and on and on. So up until the first 20 elements in the periodic table, which is starting from hydrogen and ending to the 20th element, the electronic arrangement of the atom of those elements looks something like this. This is wherein you have the nucleus, and in the first shell you have 2 electrons, and that is the maximum capacity of the first shell, you guys. Then comes the second shell, and therein it can fit 8 electrons. So that is the maximum capacity of that particular shell when it comes to up to the 20 elements in the periodic table, the first 20. And then in third, you have another 8. And then in fourth, you have another 8. So up until the 20th element in the periodic table, the electronic arrangement is 2 maximum capacity, then 8 maximum capacity, and so on and on and on. Above 20, the third and the fourth shell has the capability of housing around 18 electrons. So the maximum capacity of the third and the fourth shell increases from 8 to 18 when you go beyond the 20th element. So guys, so far we discussed that in an atom, the electronic arrangement is based on number of shells. And the number of shells ranges from the closest to the nucleus to the farthest. So these are the electronic arrangement that we were talking about, and that started from the first, which is hydrogen, to the 28, which is calcium. And up until calcium, the structure looks like the first shell houses a maximum capacity of 2 electrons, the second shell houses a maximum capacity of 8, so on and on and on. But how do we find the electrons, or how do we really understand how to divide, say, even if it is for the first 20 element in the periodic table? Pick one in any of the first 20. Let's say sodium. So sodium has an atomic number of 11, right? So how do we arrange its electrons? How do we know what is its electron number, for crying out loud, in the first place, right? So atomic number of an element is the key. Atomic number, as we know, is also the proton number of that particular element, which means that an atom of sodium contains 11 protons, right? So, we know that in a neutrally charged atom, the total number of protons, and I will urge you to listen to me very carefully right now, in a neutral atom of any element, the total number of protons and the total number of electrons must be the same, so as the positive charges should balance out the negative charges. If there is an excess of any of these charges, the atom will be charged and then will be known as an ion, something that we have discussed in detail in the chapter Chemical Bonds and Structures. If you see into the descriptions or on your column, on the column on your right, you may find those videos, and those videos might be helpful for you. So moving on to our topic, in a neutral atom of any element, the total number of protons and the total number of neutrons are the same. So if this is the number of protons of sodium, we can safely assume that this is also the total number of electrons in an atom of sodium, right? So we have 11 electrons, and we have to classify them according to the number of shells. We have to break them down, total number of electrons, in the shells that we have been provided with. Okay, so let's do it. It shouldn't be that hard, right? So 11 electrons, we know that we have to divide it via 2, 8, blah, 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 right? So in the first shell, 2 electron goes away. So if you take away 2 electrons from 11, the total number of electrons that are left is 9. So in the next shell, that is 2, we know that it has a capability of housing of a maximum of 8 electrons. So then you got 8. So 2 plus 8 equals 10. So the number of electrons that will reside in the third shell, that will be found in the third shell, is 1. So there you go. This is how you arrange electrons of an element. And you can use this formula of breaking down the electrons into its respective shells for almost any element. For example, let's pick one again. Let's say carbon. So carbon has an atomic number of 6. Right? So 6 is a little bit difficult because how do we then break it down to the 8 and the etc., right? So let's begin with the first shell. So you have 6 here. In the first shell, you have a maximum number of 2 electrons. So 2 goes away. How many electrons are left then? 4, right? So in the second shell, you house 4 electrons. And that's it. That's the electronic arrangement of carbon. And in this way, you can do the total electronic arrangement of any element from the first one to the 20th one, that is from hydrogen to calcium. You can break them down. Let's do calcium, for example. Calcium has an atomic number of 20. Okay? So, if we were to break down 20, what we would do is 2 in the first shell. So 18 more are left, right? 8 in the second shell. So 10 more left. And then we know after the second shell, the third shell can also house a maximum of 8, right? So 8. So 2 plus 8, 10. 10 plus 8, 18. So how many are left? 2, right? That goes in the fourth shell. So there you go, the electronic arrangement of atoms of elements. And this is how you do the math. This is how you break them down into their electronic structure and understand how many electrons might there be. So see, these electrons in here, the 1s and the 2s, these are also known as valence electrons or outermost shell electrons. because these are electrons that are either found in the third shell as a lone ranger moving away all on its own, or in the fourth shell with a lot of space, a lot of moving about space within them. Like the first and the second and the third shell are completely full. In case of calcium, 2, 8, 8. The last shell, although it can house a maximum of 8, there is only 2. So these electrons are mostly moving about very freely. They're farther away from the nucleus, and so they are known as valence electrons or outermost shell electrons. So guys, at this part of the lecture, we are going to talk about the periodic table. What is a periodic table? For your ease of understanding, this is what a periodic table looks like. Now, you can find the diagram of a periodic table behind your chemistry textbook or your chemistry practical book, or you can Google it out. So a periodic table is a table in which all the elements that we know of are carefully arranged on the basis of their outer shell electrons. So the elements that have similar outer shell electrons are classified together, and those that have different classifications. To dissect and then understand what a period or how the elements in the periodic table are arranged is something that we will discuss right now. So let's dig in. In the following diagram, this is a very loose representation of the periodic table. You see that the periodic table is made up of vertical columns and horizontal rows. So in a periodic table, the electrons are arranged in the order of their proton number, that is their atomic number, and then they are put in horizontal rows known as period. So these rows, these horizontal rows, and if you go up, even if there is nothing here, if you go from here to here, from the left to the right, if you move around like that, the elements are arranged according to their atomic number. So if the first element is here, the second element would be here, third, fourth, fifth, sixth, etc., etc., etc. So, in a periodic table, the elements are first arranged according to their atomic number. They are then put in horizontal rows, and these horizontal rows in a periodic table is known as period or periods. So, horizontal rows in a periodic table are known as periods. The periods are then arranged so that they form vertical columns. And these vertical columns each contain elements with the same number of outermost shell electrons. So when you put together these periods, wherein first element, second element, third, fourth, if you go from this side to this side, if you go from left to right, you see that there is a gradual increase in the consecutive number of elements. But if you go from top to bottom, you see that even though the number of outermost shell electrons remain constant, the atoms of the elements tend to grow bigger in size, which is apparent from the increase in their atomic number. So, if the horizontal rows in a periodic table are known as periods, the vertical column, which each contains, like this is one element, and then this, and also on this side, this side, this side. So each houses one element, and this element and this element and this element, each of them has the same number of outermost shell electrons. So this vertical column in a periodic table is known as a group. And the vertical columns altogether, 8 of them, are known as groups. So vertical columns are known as groups. So this is the first group, this is the second group, third, fourth, fifth, sixth, seventh, and eighth. So there are at most 8 groups in a periodic table. And another factor, another important trend that you must know about the periodic table is that as you go from the left side to the right side of the periodic table, metallic structure diminishes. From here, you have all metals. In the first and the second group, you have all metals, guys. And then as you go on the rightward direction, you move into the non-metal territory. So metallic character diminishes as you go from left to right. And at the last at the last group, at the very last group, which is known as 8, and sometimes in some periodic tables in your book or when your teacher is explaining, it is also known as group 0. The element in this group is known as inert or noble gases. Why? Because as we have discussed when we were talking about electronic arrangement, we talked how the last or the third shell can be completed by a total of 8 electrons when it is up to the first 20 elements, and above that, third or the fourth shell is completed when there is a total of 18 electrons, right? So why are the group 0 or the group 8 elements considered inert? Because their outermost shell is always completely full. So in group 1, the peculiar thing about group 1 is that each element in group 1 has an outermost shell electron number of 1. Let me show you how. So let's look into 3 elements from the periodic table, each belonging to group 1. These elements would be lithium, sodium, and potassium. Lithium has an atomic number of 3. Sodium has an atomic number of 11. Potassium has an atomic number of 19. So, if we break down the atomic number of the atoms of these elements, we'll find that lithium has an electronic arrangement of 2,1 or 2.1. And sodium has an electronic arrangement of 2, 8, 1. And then potassium has an electronic arrangement of 2, 8, 8, 1. So one thing is always common between these 3 elements is that at the very last electron of all these 3 elements has the number 1. As a result, all of these 3 elements can be found in the first group of the periodic table. And this is the trend that is followed in all the groups. So when we are thinking about the elements that are found in group 2 of the periodic table, so as I was saying, the 3 elements that we can consider from group 2 are beryllium, magnesium, and calcium, which is also the 20th element of the periodic table. So beryllium has an atomic number of 4. Magnesium has an atomic number of 12, and calcium has an atomic number of 20. So if we were to break down the atomic numbers into the electronic arrangement of these elements, we will find that beryllium has an electronic arrangement of 2, 2, magnesium has 2, 8, 2, and calcium has 2, 8, 8, 2. So, like before, you see the outer or the last electron, the last number of electrons of each of these elements are the same, 2 and 2. Even if the number of shells increases as we go from one element to the next, last number of electrons remain the same, as a result of which they are found in the second group of the periodic table. And this is the trend that is followed in each of the groups. So the outermost shell electron in group 3 is 3, 4 is 4, and so and so and so, up until we reach in the 8th or the noble gas group or group 0 also, in which the total number of electrons in the outermost shell is a complete octet or a full shell. Therefore, it is also known as a complete inert gas group. And therefore, these gases in this group tend not to react at all in chemical reactions. So guys, we have moved on to the last topic of our lecture, which is electronic structure. If you concentrate on the table on this side, you see that these are the electronic structure of the first 20 elements of the periodic table. Now, we know that they start from 1, these elements, they start from 1 and they end at 20. The first one being hydrogen and the last one being calcium. So, when you break down the atomic number of these elements into electronic structure, this is what it looks like. So, we start with hydrogen with an electronic structure of 1, helium 2. And when it comes to lithium, the atomic number 3 is broken down to 2, 1. And then in beryllium, it's 2, 2. So there are 2 in the first and 2 in the second. In boron, the first shell has 2, second has 3 because its atomic number is 5. See, 1, 2, 3, 4, 5. 6, in the sixth element, you have 2, 4. The first shell has 2 electrons and the second has 4. After 6, in the seventh one, you have the first shell which has 2 electrons and the second has 5. And as you move down, you in the end go downwards to the 10th element or neon, in which the atomic number of neon is 10, right? So in the first shell, we have 2 electrons. And in the second, we have 8. So the second shell is full. It can house no more electrons inside itself. So if we are to put further electrons, or if we are to introduce an element whose atoms contain electrons more than 10, what is going to happen? This is where the third shell comes to play. So in here you have sodium, which has an atomic number of 11. So in case of 11, the first 2 shells are filled up to how neon is filled up, to 8. And then you have 1. That 1 electron goes on to the third shell. See? 2, 8, 1. And in case of magnesium, which has an atomic number of 12, so 2, 8, which is 10, which is also the electronic structure of neon, and then the last 2 moves on to the third shell. And this is how, exactly like its predecessors, the third shell is being filled. 1, 2, 3, 4. In case of magnesium, it's 2, 8, 2. In case of aluminum, it's 2, 8, 3, because aluminum has an atomic number of 13. And silicon, 2, 8, 4, 14. Phosphorus, 2, 8, 5, 15. Sulfur, 2, 8, 6, 16. Chlorine, 2, 8, 7, 17, 18. And then when 18 happens, which is in case of argon, the third shell is filled up to its maximum capacity. So in the third shell there are 2, 8, and 8. 18. Completely full. But then we have another two elements which has an atomic number that is higher than 18. So we have electrons that are more than 18. So how do we house them? How do we fit them in? Therein the fourth shell comes to play. See, in the 19th element, which is potassium, the first three shells are exactly like in case of argon. And then the last electron, the last one electron, goes onto the fourth shell. In case of calcium, the last two electrons goes onto the fourth shell. So you see, this is how electronic structures are being composed. We start with filling up the first shell. In case of hydrogen, the first shell contained one electron, and in case of helium, the first shell had two. And then when further electron arise, the second shell started to fill up. And then when the second shell was filled up to its maximum capacity, the third shell came to play. And when the third shell was filled up to its maximum capacity, the fourth shell came into play. And this is how electronic structures are composed. So guys, with this lecture, the chapter Atomic Structure in the Periodic Table is concluded. I hope that whatever we have discussed in the chapter Atomic Structure in the Periodic Table, you were able to follow through and understand the nuances on the structure of an atom. You were able to follow through isotopes, nuclear energy, the periodic table, electronic arrangement, and etc. And also, you were able to follow into the history of how the atom was discovered and the theories on which the atomic structure was based. So, if I was able to help you understand all of these topics with my lecture, I hope you subscribe to our channel. And if you have any questions, please direct them to our comment section. And until the next chapter comes along, have a nice day.